Hello everyone. In this lecture, I am going to show some familiar computations using Newton-Raphson method. The first case is computing the square root of a positive number, and n can be any number. We need to get the square root of the number n. That means root n is to be determined, like root 10, root 11, root 13, etc. So for this, we need to develop Newton-Raphson formula first, for which we need to form a function f of x, for which we are taking x as some root n. So by squaring on both sides and modifying the expression, we are getting x squared minus n equal to 0. This is of the form f of x equals to 0. Hence, we choose f of x as x squared minus n, so that its derivative is 2x. In the previous lecture, we have derived Newton-Raphson iteration formula. The formula is xn plus 1 is equals to xn minus f of xn by f dash of xn. The same will be equivalent to xn plus 1 is equals to xn minus f of x is nothing but x square minus n, so that we write f of xn as xn square minus capital N by f dash of xn. F dash of x is 2x, so f dash of xn is 2xn. By simplifying this expression, we will get it xn times of 2xn is nothing but 2xn square minus xn square becomes xn square, and minus of minus n will become plus n by 2xn. Finally, the iteration formula to find the square root of a positive number n is to be taken as xn plus 1 equal to xn square plus n by 2xn, where n starts with 0, 1, 2, 3 and so on. Any iteration method will start with some initial guess. By taking x naught as the initial guess, we will start finding sequence of approximations x1, x2, x3 and so on. As usual, the iteration process can be stopped when two successive iterations are same up to the desired accuracy. So hence, if you want to find the square root of a number n, then directly we can use the iteration formula xn plus 1 equal to xn square plus n by 2xn by taking the initial guess x naught. Let us see one example. Find the square root of a number 18 using Newton method or Newton-Raphson method. So here we are showing that we are taking x as root 18, so that by modifying this we will get x square minus 18 equal to 0. From this we can choose f of x as x square minus 18 and f dash of x equals to 2x. So we are directly taking the iteration formula from Newton-Raphson method as xn plus 1 equal to xn square plus n. This n is nothing but a number to which square root is required. Here for 18, square root is required, so we are just placing n by 18 by 2xn, then equal to 0, 1, 2, 3 and so on. Now x naught is to be chosen. It is very clear that if the initial guess is near to the exact solution, then our Newton-Raphson method converges fastly. So we are taking initial guess 4.5 near to the value of root 18. It's very clear root 18 lies between 4 and 5. The average of 4, 5 is nothing but our 4.5. Hence we are choosing x naught as 4.5. Let us start finding successive iterations. For the first approximation, we can put n equal to 0 in the formula, so that x1 will become x naught square plus 18 by 2 x naught. By giving x naught equal to 4.5 in this and simplifying, we are getting 4.25. Now using this first approximation, we can find the second approximation, for which put n equal to 1 in the iteration formula. So that our second approximation x2 will become x1 square plus 18 by 2 x1. x1 is 4.25. You can use that in this expression. By simplifying that, we are getting 4.2426. We can compare successive iterations. So here we can see that the two successive approximations are same up to one decimal place accuracy only. Hence, we need to continue to finding successive iterations. Now, using the second approximation, we are finding the third approximation. The next 3 is given by x2 square plus 18 by 2x2. Using this value here and simplifying, we are getting 4.24. Now here you can see that in the two successive approximations, the two values are same up to 4 decimal place accuracy. So usually we can stop iteration process with 4 decimal place accuracy for any problem if anything is not mentioned in the given problem. So here the second and third approximations are same up to 4 decimal place accuracy. Hence we can stop iteration process and decide the required solution as 4.2426. We are giving the conclusion like since the second and third approximations are same up to 4 decimal places, then stop iteration process and take the required root as x equal to 4.2426. This is one case of uh, Newton-Raphson method. Let us see another case. So here we want to find reciprocal of a number n. As usual, to develop Newton-Raphson formula, we must have f of x first, for which we are taking x is equals to 1 by n. Reciprocal of n is 1 by n. We are letting it as some x. And by modifying this, we will get that 1 by x equals to n. Deriving this, we will write 1 by x minus n equal to 0. This is of the form f of x equals to 0, from which f of x is 1 by x minus n. By differentiating this, we will get that f dash of x equals to minus 1 by x square. Now, by Newton-Raphson method, we have the iteration formula xn plus 1 equal to xn minus f of xn by f dash of xn. This is equals to xn minus f of x is nothing but 1 by x minus n. So f of xn can be taken as 1 by xn minus n by f dash of xn. F dash of x is minus 1 by x square. So f dash of xn is minus 1 by xn square. Then n equal to 0, 1, 2, 3 and so on. Now by modifying this, you'll get in next step xn plus 1 equal to xn plus xn square into 1 by xn minus n. By simplifying this, we will get xn plus 1 equal to 2xn minus n xn square, where n is equals to 0, 1, 2, 3 and so on. So when we want to find reciprocal of a positive number n, then by Newton's method, the iteration formula can be directly taken as xn plus 1 equal to 2xn minus nxn square. If we want to find the reciprocal of 19, then the iteration formula can be taken as xn plus 1 equals to 2xn minus 19xn square. Now by taking initial guess x naught, we will start finding successive approximations. Let us see one example. Let us see an example. Find the reciprocal of a number 11 using Newton's method. Here n is equals to 11. Reciprocal of the number is nothing but 1 by 11 is to be determined using our Newton's method. As we have seen just before, we are taking the reciprocal of the number as some x and modifying this, we are getting 1 by x minus 11 equal to 0. This is our f of x. 1 by x minus 11 is our f of x. Then its derivative is minus 1 by x square. And by Newton's method, we can directly take iteration formula to find the reciprocal of a number as xn plus 1 equal to 2xn minus 11 xn square, because n is equals to 11. Now, iteration process to be done by taking some initial guess. We are choosing x not equal to 0.05 here. It should be taken very carefully. We all know that 1 by n, whatever n value is, it always lies between 0, 1. And there are infinitely many values between 0 and 1. Hence, you should choose x naught very carefully, for which you should always find what is the exact value of 1 by n using the calculator. Here you can see that 1 by 11 value is 0.0909, etc. So, for the faster convergence, we should take the initial value which is near to 1 by 11 value. That means here you can see that 0.0 after which you have a non-zero element. So this 0.0 should be as it is. After which, instead of 9, you can take any non-zero value from 1 to 8. You can also choose x naught as 0.01, 0.02, 0.07, etc. But here I am choosing a near value 0.05. Now I need to improve this value, and after some time, after few iterations, I will reach to this exact value. Let us find successive approximations. The first approximation x1 is given by 2x0 minus 11x0 square. This is obtained by keeping n equal to 0 in iteration formula, using x0 equals to 0.05 in this, we are getting the value of x1, 0.0725. This is the first approximation. Using this first approximation in the iteration formula, we are getting the second approximation, that is obtained as 0.0871. Here we can observe that first and second approximations are different. So we need to get next iterations or next approximations, for which we are writing the next approximation, third approximation. In the iteration formula, we put n equal to 2, then x3 is equals to 2x2 minus 11x2 square. Hence the value is 0.0907. Again, we can observe second and third approximations are different. Hence, we should get the next iteration. So, using third approximation, we are creating fourth approximation. This is obtained as 0.0909. It is very clear, third and fourth approximations are same up to 3 decimal place accuracy. We may stop finding our iterations. For better accuracy, I want to get at least 4 decimal place accuracy, for which I am going to get the next approximation also. Using this fourth approximation, the fifth approximation is given by 2x4 minus 11x4 square. Using 0.0909 in this, we are going to get x5 as 0.0909. Now you can observe fourth and fifth approximations are same up to 4 decimal place accuracy. So that you can stop iteration process and take the root of the equation as x equal to 0.0909. Equation is nothing but x minus 1 by 11 equals to 0. Its solution is nothing but 1 by 11 equals to x. This x is obtained as 0.09. 0.09. Hence, the approximate value of 1 by 11 is 0.0909. The actual value will be 0.0909 and so on. There are some other examples. Finding cube root of a number, etc. You can do it on your own. Let us see some more examples in next lecture. Thank you.